Great. So yesterday, so I saw your answers. All of you have submitted your, almost all of you have submitted. Okay. And and probably this would be my first batch where I have got the highest number of good, correct answers from session number two. Okay. So this is probably the best batch. Okay. Although the smallest batch, but this is probably the best set of candidates. And I've gone through your answers, and I've also reviewed some of the answers, and also have given you the suggestions for the improvement. So please go through those suggestions for improvement. They will, they will work well. Also, I'm talking about the MapReduce assignment. Okay. Also, in the meantime, it would be great that you build your GitHub profile. Okay. So on GitHub, you can post your solutions and then I can review it there. All right. Those who have already submitted, that's good enough. But if you want to put it on GitHub, that would be good. Okay. Just in the description at GitHub, just mention that it's for the KnowBigData, and that's all. All right. Because that way it becomes easier for me to review. And on the other way to look at it is that it builds your general developer profile better, a social profile. And also you will get to learn things like Git and markdown format and Git. Those kind of things you will learn on the way while you will post things onto GitHub. Okay. And probably the best way to learn any software is by looking at what people are doing. And when you look at other people's code or other people's product, that's how you learn better than anything else. Okay. Suggestions are shown on course page. Not really, not really. So basically, those suggestions which I'm talking about is with respect to the code which you have submitted. All right. And let me have a look at the other. So Abhinav and Sushant, you have submitted your code on the website itself in the subjective quiz. Okay, okay, then I'll have a look at it maybe tomorrow. All right, all right. So for you, I'll have a look at it there and then quickly review it and then finish it. Okay. The all I was explaining is that if you go to because whether our website or whether via email, the code review is not great. As of today, we don't have a better code review tool than what we have at GitHub and elsewhere. So I was suggesting that you can start maintaining your GitHub profile, and that way you will get noticed. Okay. So all right. So let's continue where we left yesterday. I was talking about session number two's answers. Okay. So let's discuss where I left yesterday. Turning off my phone. All right. So Yeah, I think I sent the review back. And I think I sent a review back to Seema as well. Okay, so what do I need to do is Seema, Sushant. Anyway, I'll just have a look at it again for the class and then we'll inform you accordingly. Okay, okay. Oh, no, I think I have sent to at least 3 to 4 candidates in the session. Never mind, never mind. I'll just have a look at what who all I have sent it to, and then I'll. All right. So, so starting with today's session, let me. Okay. So till yesterday, we just described the general architecture of HBase, and then we had just started the data model. So the most important thing for a user of HBase or a developer of an HBase is to understand the data model. A data model, the most crisp way, is described by Bigtable itself, as HBase is built on the same model as Bigtable. So Bigtable gives the best form of the explanation to that paper gives the best form of explanation. So it says that Bigtable is a sparse, distributed, persistent, multidimensional, sorted map. So many keywords, and each keyword means a lot. Sparse means, now think of a table in which only few columns are full while other columns are free. It's like a sparse matrix. So for first row, maybe the third column is full and rest of the columns are free. For second row, the fourth column is free and fourth column is full. Fourth column has some value while others are free, and so on. So for a row, except for few columns, everything is vacant. So that kind of model is called sparse. Second, distributed. It's a map which is first sparse, and okay, let me describe what is a map. A map is something, a key value pair which has a key and it has got some values. Okay, the most important part of a map is it has a key which you can immediately look up, and generally the lookups are very fast. So a value could be anything, that's irrelevant. Now, I mean, not too irrelevant, just that map can have value as null as well as have some value. So, big table is nothing but a huge map where it could be sparse and it could be distributed, as in the some part of the map is on one machine, some part of the map is on another machine, and so on. Third portion of the definition is persistent. Persistent as in this map is stored on the disk. It is not in the memory the way any of the data structures represented as a map are. Most of the data structures when we define as map are generally in the memory. So persistent means they are available for ever. I mean, even if the machine shuts down or whatever happens. The fourth keyword is multidimensional. Multidimensional as in It's not only the key which defines the value, there could be multiple things which can define the value. Meaning, the key is a composite thing. Key 1, comma key 2, comma key 3, comma key 4. That is multidimensional. So a key is composed of multiple things. It could be an object, it could be a byte array, and so on. Okay, so that is what we call it a multidimensional. So key 1 comma key 2 can be used to look up in this map. Unlike the usual key value, here we can say give me look up things based on key 1 and key 2. So that is multidimensional. Third one is sorted. Sorted as in keys are sorted. So if you get hold of one key in this map, you can start moving from that point downwards till the other values. Okay. So if you got hold of key 1, the first key, then if you go to next one, it will be lexically in the next order. Okay. So 5 keywords or 6 keywords, a big table is nothing but a humongous map where the values could be sparse, it's distributed, it's persistent, and it's multidimensional, and it's sorted. Okay, so the way we had looked at a database, we always looked at it like a big table, like a table. Here, the definition is damaged badly. It would look like now a big hash table. Okay, like more like an array. You put an index, you get the value. Okay, or a matrix where you can look up for a value given I comma j. That's the kind of way you need to think about this. All right. So a big table is this, and exactly same is the definition of HBase. Okay. Now, few of the things which so why I'm discussing all of this is this will help you design your data model, and I'll focus more on the data model because that's where everybody gets stuck. Okay, when it comes because I have consulted with lots of friends who are stuck with Cassandra. They think that how should I design my data architecture, although they have studied Cassandra and HBase. The problem is they studied everything the way traditional relational database is. So there are few things we need to understand. Okay, so data model is probably the primary important thing, because for installation you don't require much engineering from your side. For deployment, not much engineering is required, but much engineering is required when you're building your solution. Okay, now, and I also faced when I was for the first time working with Cassandra and HBase at InMobi, I realized that I lacked the knowledge that was required in the place. I had studied everything, I have started using it, I was using it, but the moment I had to build the solution, I was stuck at the design level, and then I had to go back and understand exactly why we are doing the things the way we are doing and how can we do it better. All right. So before we begin, let me just describe things. A table, which we all know, table is a data structure which HBase provides you. But beneath the hood, a table is nothing but sort of a matrix where you provide row and column and it gives you the value. Okay. So basically, table is like a map here where you say table, give me key and give, sorry, for a row and for a column, I have got some value for you. Okay, a value for you. So this is what a big table or HBase looks like for the end user. All right. Now moving ahead. So the HBase organizes data as tables. These tables are sparse, as in the for some column row there are values, for some column rows there are no values at all. Okay, having the row key or the row header is mandatory. Unlike our relational database, where we had in a relational database table we had only columns. Okay, just a second, I will have to answer to people. All right, so okay, I had muted everyone, so that's the reason the sound was gone. Okay, now moving ahead. Now, so generally in relational database, it was not mandatory to have ID. ID was not mandatory in case of a relational database. Okay, so but having the columns was mandatory. But here, when you are defining a table, every table by default has to have a row key. Row key is the primary thing. When you look up for something, you look up for a row key and then you look up for the, okay. Now, now table names, the name of the table it has to be something very, something with which a file name could be created. Okay, because with the table name a file on hdfs is going to be created, therefore the table name have to be sensitive, safe. Okay, and why I'm focusing on saying safe you will understand in a minute. Okay, Julie's question is how complex a row could be. A row could be anything. The value in the row could be anything. It could be bytes. It could be, basically it could be bytes. Okay, and a row can have a billion columns. That's not an issue for HBase. Okay, so basically the values in a row. Okay. How complex can a row key be? Okay, so a row key is, it has to be bytes. Okay, which means anything could be the row key. Integer, string, object, anything represented as bytes could be the candidate for row key. And you will understand what kind of row key you need to build in order to achieve your objective. All right. Now, a row within a table, the data is stored according to its row, and rows are identified uniquely by their row key. Unlike in relational database, it's difficult to identify a row if they don't have an ID. Here, having a row ID is very important. Okay, and row key has to be unique. Okay, row key cannot be duplicated. So you can think of like a primary key. You have to have a row key in every table. Like with any NoSQL, HBase is no different. Every row has to have an ID. Can there be different row key for different rows? There have to be different row key for different rows. All right. Now, now within a table, a data is stored according to its rows. Now, row key does not have to have a data type. It are treated as byte array. Okay. Now, after that, first we define table, then rows, then column family. Column family is bunch of columns. Defining column family upfront while creating a table is mandatory. Okay, it's difficult to redefine the column family again or add a column family again. There's no straightforward way of adding a column family again in a database table. Right? So data within a row is grouped into column families and impact the physical column family essentially impacts the physical arrangement. As we showed you, how does the arrangement of column family kind of a database, column family oriented database looks like. And every row in the table will have the same set of column family. That's the another thing. Whether you put a column in it or not, it's completely dynamic. Okay. So columns are dynamic, but column family is static. Okay. Uh, Another thing is just like tables, column families need to have safe names because you cannot have simply bytes. They have to be strings that to because HBase is going to create names of the column like this. Okay. While row key can be anything, column family and table name cannot be anything other than the file safe strings. Okay. All right. Now, Julie's question is: should the row key be built from the data like in a relational DB? Yes. Okay. And the decision to build a row key would be based on what is it that you will look with in this database. Okay. All right. So now there's something called column name or column qualifier. Unlike the normal way we had been looking at the column, here column is more like more like a value which you can store dynamically. Yes. Sushant is saying that so big table can be looked at multiple appended tables appended into one table architecture. So you can think of each column family as a separate table itself. Okay. Yes. Now, generally, the way we had been defining relational databases, we define column names, which are nice things, but and we which are static. Here, column names are dynamic. A for one row, there could be a million column in a column family. For second row, there could be only few columns in a column family. Okay, and the column name when you are defining a column name, when you are inserting data into a row, you can add any value in the column. It can be a byte array. Okay, whether it's a string, integer, long, or it's an object, whatever it is, you convert it into bytes and put it there. So which means that column is not just a placeholder, it also stores the data. The way you have row key where you are storing an id or some value, similarly the column key is also a dimension which you will keep storing. data into. Now, the cell is the one, the cell is a place where you will be storing a piece of data. So you can say X, when you say in a matrix, when you have X and Y, two-dimensional matrix, you have X comma Y, and you have a big matrix saying matrix X comma Y equals to this value. That value goes into cell. Okay, if you look at big table the way I'm looking at a big table like a humongous matrix, where humongous sparse matrix, where there are two dimensions on which I can look up. One is x, other is y, and I can set some value. Okay, the value again can be of byte type, byte array. Okay, Abhinav's question is, can you please show some examples how HBase stores data? It will augment the understanding of these characteristics. So let me finish the definition and then I'll take you through the storage as well as two examples of the design. So column family is static, but columns inside column families are dynamic. Yes, that's exactly the way it should be put. All right. Now there is the cell value could be multiple. In order to have a distributed system, because there will be multiple people would be trying to store the data, it is always sensible to maintain the versions of the cell values. Okay. So a cell value is versioned, which means as you put in the data, the old value is pushed to a older version, and this one becomes the newer version which you are putting now. And the key for the cell value then becomes timestamp. For timestamp 1 we had this value, timestamp 2 this value, timestamp 3 this value. So by default the way version is defined is based on the timestamp. Okay, so how many dimensions we got? We got x, I mean row key, column key, cell value, and timestamp. So a value is defined based on what is your row key, what is your column key, and what is basically your timestamp you are looking for. If you do not provide a timestamp, the most current value is returned to you. Okay, and by default HBase stores only three versions, the most recent three versions. Okay, yeah. Sushant has got many questions. So retrieval of lesser timestamp, storage space, duplicate data, etc. Yeah, keep on asking those questions. So basically, you can define the number of versions you want to retain in a table. It's up to you. You can change it. But have and storage space, definitely it consumes three times of space. But since by definition the table have to be sparse, that means the it will only consume the space in which there are the values, unlike in a relational database where even if you do not store a value in a column it consumes the disk space. Here that's not the case. So how about a team of six people working on a big table simultaneously? A lot of conflict of data processing. So since it's a master slave kind of architecture, the HBase master is not like your MongoDB. It basically it's a strongly consistent database. So even if there are six people working, they all will be going through the HBase master, and they will be doing. I mean, HBase master takes care of the versioning really well. Now, This is the logical view, the way you look at a H-based table. You have got row key, say 0, 1, 2, 3, 4, 5, 6. Here is just for the simplicity reasons, we are thinking of row key like this. Okay. And row keys are lexically sorted. Okay. And in this table, you have column family. One is called personal, other column family is called office. Under personal, you have a column called name, and second column is residential phone. Okay. Now, under similar is similar. There are two other columns. Now here, this table is very decent, as in it has got really tabular structure. And for each value, as you can see, like the one which is highlighted, there are going to be multiple versions. So this is how you can think of the table. So this is a table, there are column families, and then there are columns, and then there is a row key. This is a very decent table, very similar to RDBMS, but in reality, you will realize that only when we talk about H-based tables, they are really sparse. Meaning, out of a million columns, there will be only two columns which are full. Or out of 10 million columns, there will be only 10 columns which are full. Rest of the columns are free. And these are only any 10 columns. So the data, I'll show you in a minute. Now, the same thing when it's stored onto HDFS by HBase looks like this. Okay. For a row, there is a folder. For a row key, there is a folder 0001. Then there is a folder called office for one column one, one column key, sorry, one column family, and then there is a column, and then there is a timestamp, and there is a value. Okay, so this is another way of looking at the data model. Okay, so you have got how many dimensions for reaching to this place? You have got row key, column family, then row key, column family, then column, and then timestamp. So you got four dimensions to define a data. Okay, row key, column family, column, and timestamp. Although whenever you are accessing a column, you generally combine the column family and column together. Okay, because address personal comma address does not make any sense, because personal is a different column family which does not have something called address. Okay, but from query perspective, that still makes sense. All right, now let's have a real example for which the whole big table was invented. Big table was basically invented to store the data of the whole world, the data of www. The data is 500 terabytes minimum. Okay, so even if you crawl the whole database, whole world wide web, it is close to 500 terabytes, as per my understanding from public datasets available at Amazon. So so HBase table was actually, big table was designed for that purpose. Now, Google has to compute something called a page rank. A page rank is computed based on how people are referring to your website and which all people are referring to your website. So there is a website like Apache. If they refer to your website, that means you have got a good page rank. And the moment you get a good page rank, if you start referring to somebody, they will get a better page rank, and so on. So it's like the people with better vote counts, if they vote for somebody, they get further better vote counts, and more the people vote for somebody, the better they get. So that is how a page rank was computed. And so to compute the page rank, they needed to know that which website has got referred by who and how. If I'm referring to your website, sometimes for education material and sometimes for music, that means there is something fishy going on. Okay, so if that means that your website is not really authoritative source of information, and hence your website will not be given a great rating. So those are the parts of the algorithm at, at Google, and for that they needed to have the structure in place. So there is a website, what does it contain, how people are referring to it. Okay, so to architecture that, they designed a table like this. The row key is the domain name in the reverse. Okay, so the row key is domain name, that too in the reverse, which means the this is basically www.cnn.com, cnn.com. Okay, also you can see that c is com, it's not moc. Okay, which means strings are intact, each individual part of the domain name is intact, it's just that the parts are reversed. Okay, why did they do it? So that so that all the domain names which belong to cnn.com come together, because in the definition of big table it said it's a sorted hash, sorted map, right? Therefore, if there is another domain name called com.cnn.ww2, or this one, they will come next to each other, right? When you have a lexical sorting. So unlike your usual Java hash map where the keys are not sorted, but there is a data structure called sorted hash map where keys are sorted. So if you locate www.com or if you locate cnn.com, the rest of the things you can just iterate. You don't have to look up again to find out all the subdomain of cnn.com. Okay, so keys are sorted, so they took an advantage of that one. Had they stored the keys like this, the key name should had been www.cnn.com and say mobile.cnn.com. So here this one would come before this, and here the mobile.apple.com would come, some other website, and and then maybe mobile.google.com. So once you locate a particular domain name, you will not be able to find another subdomains under that. Okay, you will have to keep on looking it forever. Therefore they did a clever thing, they utilized this sortedness of row keys, and to utilize that they formed the row key in a manner so that they can look up really faster. All right, because the page rank, when it's computed, it's not only computed for one particular subdomain, it's computed for all the domains. So that became the row key. Okay, it's very important to understand the row key concept. So whenever you want to store the data in row key, think of utilizing the sortedness in the row key. Second was the column keys. Yes, that's right, Julie. If you have the requirement of iterating through other row keys, other subdomains, or other similar row keys which you want to bunch up together, then you form the row key in a manner that all these things come together. So the way we used to utilize the MapReduce, the way we form the key so that all the data comes together. Similarly here, we will intend to have the same inclination to bring the data together. Okay, so so you downloaded the data for www.cnn.com. It created a column family called contents. Under contents, there is one column called normal HTML. There could be another column called PDF. There could be another column for binary, as in music, and so on. So under contents as the column family, there could be multiple columns. Here by default there is a column can also have a blank name. Okay, so here the column name, the default one is your HTML, and that's what it is. So you got this data. So for if you want to just find out what is the data of a website, you just go to this row key and then you go to the this particular column and you get the data. Now there is one more thing we wanted to store. We wanted to store who all are linking to CNN and how are they linking to CNN. For example, cnnsi.com is having a link on their website to cnn.com, and while writing ahref, the way they are referring to it, they must have written something like on www on cnnsi.com there must be a link like this: ahref www.cnn.com, and then you have capital CNN like this. Okay, while on mylook.ca there would be another link like this, and they all have a this one has cnn.com like this. Okay, so basically if you see, this table is expanding in both dimensions, horizontally as well as vertically. Okay, but vertically as in when more and more domain names are searched, more and more rows are added to it, and when more and more website you visit, more and more you find that these are the this website is linking to this website, that website, and so on, you start adding these columns. Okay, so for column name does not need to have system safe values, while column family name does have, while table name has to have system safe. So anchor column will be added on the fly. While anchor is a column family, but cnnsi.com, my.look.ca, these are the name of column. Okay, and you will keep on adding. So there could be for www.cnn.com, if a million people are referring to that website on their websites, you will keep on adding these columns into this. So a row with a key called com.cnn.www will have a million rows, sorry, a million columns under the column family called anchor. Sounds good? So this is probably one important aspect to understand when you are designing these systems. Okay, so whenever you want to do a lot of humongous data loading, probably HBase will be a better suited as compared to MySQL. But if you have a requirement of a relational data strongly, you would choose to have something like MySQL, and you'll be happy with that. Okay. Yes, exactly, Abhinav. So if one more website xyz.com refers to it, then it will have one more column and the value will be news. All right. If it is referred to like that. So pay attention to it. So this will keep on increasing, adding more and more columns to it. And similar is here. Right now it's just HTML. Tomorrow a new format comes into play. They'll have more columns under contents. Okay. So if you understood this design, okay. So the timestamps point to slide T3, T5, T6 here, T3, T5, T6, and T9. Okay. So basically at different you can keep on adding value. You don't have to insert the whole row at a single shot. You can keep on adding cell values and as and when you want. Okay. And each cell will have only three versions. It doesn't mean it just for the demonstration purpose we have written T9. It does not mean it has nine versions. It's just that it is some timestamp on ninth day or eighth day or somewhere. Okay. So Sushant, did you understand? Yes. You got it. Great. All right. Any questions on this? Should I move on? Okay. So the way it is going to get stored is like this. A column family anchor will have this row key for this timestamp. This is the value. Same row key, this timestamp. This is the value, and so on. So, okay, adding column family is pretty difficult game. The by default, HBase does not provide you semantics to alter a table and add column family, but you can create another HBase table in which you start moving the data from here. So, format of timestamp, I'll show you. Okay, so generally it's a long. The way a timestamp is represented is in UTC, and that too as a big number. Basically the milliseconds since the epoch, while nowadays we are moving to nanoseconds, but still the millisecond works here. Google internally have moved to nanoseconds. Here we are still working on milliseconds. Okay, so if I have to retrieve column value of certain timestamp, yes. So basically, in general, you don't have to always specify a timestamp to retrieve a value. You if you don't specify timestamp, the most recent timestamp will be returned. Most recent data will be returned to you. Okay. And in case you want to have specific timestamp, you can just say get me all the values, then iterate over the values and get the particular value. All right. Okay, so again, let me reiterate. Indexing is based on row key. Tables are sorted based on the row key. Each region of the table has sorted. Now you can ask a question. If it is related to this session, please ask. All right, you can send me an email or you drop me up at forum actually. Okay, and then I'll try to answer there so that everybody can read. All right. Okay. So don't worry, don't I mean if you have a question, ask it. Don't worry about the time. Okay, we can always manage time. We can have extra session. No worries. All right. Now, the reason of the table, the reason as in the when a table is divided is divided into reasons in this following format: a starting key and the ending key. And everything in HBase table is stored as byte array except for table name and column family name. And this is little important. Atomicity is guaranteed only at a row level. No multi-row transactions are guaranteed. Okay, so this is a little bit of a setback for people who are from a acid databases, the databases that support acid properties. For them, it is little a shock. So when you are updating a row, it can be guaranteed that all the changes you're making in a particular row, either all of them reflect to the end user at the same time or none of the changes reflect. So that kind of guarantee HBase provides. But it does not provide something like add one row into this table, update there, and all of this in a single transaction. So either all of these insertion updation in this table, other table, or some other operations in the table, either all of those reflect or neither of the operations reflect. That kind of acid properties are not supported by HBase as of today. Okay, only the row level guarantee is provided for the atomicity. Okay, so all of this is anyway covered. All data operations, whenever you are looking for the data in HBase, the data is sorted in the following manner. First, it is sorted by row key, then column family name, then column qualifier name, and then timestamp, and which is descending, which means the most recent one comes at the top while everything else is ascending. Okay, so a table is splitted into reasons. A reason is defined as starting from this row key till that row key. Okay, and whenever we define a reason, we define it two ways. The starting key is inclusive, while end key is not part of this reason. It's just that just before the end key, I mean, this reason will contain the start key but not the end key. Okay, it's saying like I will have a reason from 1 to 10, which means the reason will have 1, 2, up to 9, but not the 10th value. That is why the set, you see the square bracket and here the pipe. Okay. So a reason is a section of the table which is decided by the HBase automatically, and basically when you start writing to a table and the moment, so when you start writing to a table by default it's a single reason, and when the table reaches to a certain size it is split it into two halves, and the reason, so it created two reasons now. Okay, and now after that two smaller regions it has created. After that, one region will move to another machine automatically based on the availability of the space and the servers. And when you keep on adding more and more rows to either of these two sections which we have created, and when they reach to a certain size, they will again be split into two and then move. Okay. So that is how the whole dynamics of table is works. So Abhinav, was I able to answer your question? All right. Oh, that was another slide. So, okay. So a reason is denoted by table. It belongs to the first row and the last row. Last row is exclusive, which means just before this row. Okay. So initially table is comprised of a single reason. As you keep on, as the size grows beyond a threshold, re- table is split into two reasons. And before the first split happens, the data keeps on getting loaded using a single machine. So threshold is defined in HBase itself. I need to look it up. So I need to look it up. Okay. So there is some threshold which is generally configured in the beginning. I need to look it up. All right. Physically, the data is stored in this format. So when you store any data into table, it is going over here. Okay. So my net connection has gone severely bad. Do you also face this sloppiness in the connectivity to Hadoop Fun and Hue, or is it only me? Because this is screen I'm seeing for too long. Okay, so probably it's my net connection. All right. So here the data gets stored at these places. Well, because the website is taking too much time, let me just SSH. So now you can see clearly, right? Okay, so data is actually stored in this folder. For each table, for first under this, there is a table name. Okay, so similar to, so here you go to HBase shell. Oh, HBase need to be started up. It has been shut down. All right, so basically this slides I wanted to explain to you where exactly the data is stored. Okay, so the data is stored into this folder onto HDFS, and there is a folder with the name called table name. Under this folder there is another folder with the name of the reason is a random number generated for each reason of the table. Initially there is only a single reason, and then as and when more and more reasons grow, more and more folders are created in this folder. Okay, under that there is a folder name called with the name of column family, and then is the whole data set. Okay, for each column family, this is the file which contains all the columns. Okay, and this store file has got a format similar to something like RC file, which is a good format, and which is basically a good for storing the humongous data. When this store files keeps on increasing, then the it is split into two halves, and one more folder is created at this level for the reason, and then there'll be another folders for all column families, and then there'll be the data. Okay, so I think the HBase reason servers are not alive. All right, now that is the way physically they're stored. So we can go to this particular folder, and under this you can see that my first table, this is the table name I had created, and under this there is a reason server, reason number, this is automatically generated. Then there is a column family under this. Okay, and then you have dot reason info basically is uh, contains the information about reason from which row to which row it is. Okay, now this is up. The way you access HBase is by using HBase shell. And if you say list, it will show you the list of all the tables, just like you do, show tables. And say you have got Ambari smoke test, and we can say scan. Okay, so scan and then table name. Here you don't have to specify, put it in single quotes. And here it shows you that there is a row key and there is a column plus cell. Column has got family here. This is a name, and when we are described desk, let's say I say describe my table. All right, so HBase is up. Okay, so here for the same table, say first table, and here we are talking about Ambari's smoke test. And this is the file which contains the data. Okay, as you can see that it is binary file in the form of, okay, describe table. It doesn't have. Okay, so that's how it looks like. Let's go through few more things and then we'll do the hands-on. Okay, so physically this is how the data is stored. So it clears few things. First, why did we have that that mention that why should the table name should be file system safe, or column family should be file system safe, because they are going to be folder name, right? Second is that the data is stored into HDFS. So HBase has to have HDFS in order to run itself. All right. Now, locking, as I told you, it's a row level locking, nothing more than that. So when you scan the data, when you try to find the data in HBase, it's mostly done using something called scanners. Right? So HBase does not provide you a sophisticated SQL query language. For that, you will still have to rely on things like Hive. Okay, you'll have to rely on things like Hive in order to query the data in your HBase. But HBase provides you a rudimentary way of connecting to it and scanning the data. So you create something called a scanner. They behave more or less like traditional cursors in the database. And you have to close them. After you are done with them, they return the rows in an order. Okay. So when you are creating the scanner, you can define the following parameters, such as from which row key do you want to start, and on what row key do you want to stop, and which column do you want to return, and you might want to run a filter on the server side, okay, such as uh, stop when these are the column values, or something of that sort, or remove these rows from the output, because each row is going to be bulky, and you need to be, be very specific about which columns do you want to retrieve. Unlike in our traditional system, we said select star from my table where this equals to that. Here you have to tell specifically, get me the data from this row key till this row key, and these are the columns you want. Okay. And every time, like a cursor, a scanner returns you a set of results. Okay. It'll give you the data corresponding to one region, and when you again ask the scanner to do the next, it goes to the next region server for the next set of rows, and get you back the number of rows which you are looking forward to. All right. So those are called scanners. I'll show you briefly how to, and mostly when you are coding against HBase, you can get the scanner like this. You say result scanner rs and htable.getScanner. First, you'll have to define your HBase table from which you get this object, and then you get the scanner. Okay. So the architecture of HBase, again, let's have a look at it. So as I showed you, the data is going to get stored in HDFS, both metadata as well as the actual data. Everything is in HDFS. And there is something called a zookeeper cluster. You can think of like you can think of like how should I describe it? The reception of a hotel, where they all are informing at the reception of the reception, saying, "Hey, I am up, I am up, I am up. If somebody comes, the master comes to look for us, we are up." Because region servers are also separate entities that can come and go. Okay, so region server, instead of telling master directly that, "Hey, I am up," it tells the zookeeper that I am up, and master, instead of asking directly the region servers, it goes to zookeeper and asks who are the region servers available as of now. We should always connect the master data node to query the data. That's correct. All right. So generally the master redirects the driver, the software driver you are going to connect via, to read the data directly from a region server. Yeah. So region server, that's a very good point Sushant has raised. We will explain to it in a very briefly that why do we need a further layer of zookeeper. Okay. So Zookeeper is a very highly available service in itself. It's also a bunch of nodes which are running in order to provide you a sort of a traffic manager. Okay, they provide you a coordination service. Okay, now had reason server been always informing master, then master will have to keep a note of all the reason servers available. Okay, so either HBase master keeps on pinging all the region servers and make sure that the region server is alive, or they could use some somebody like Zookeeper who already has all those features. Okay, just unlike other systems like MongoDB who has built this feature in itself, where they keep on pinging and checking which one is alive and which one is dead. Instead of that, master zookeeper, they delegate the work to the zookeeper. Okay, so when we say cluster, it just has network managers. No, it's actually a bunch of computers, bunch of nodes. Okay, it's not a single node. Here, how many nodes do we have? We have Zookeeper client is okay. Zookeeper server, there is only one server as of now. Okay, there is only one server. All right, so that is the role of Zookeeper. Are you guys with me? So we'll go into the details of Zookeeper immediately after this. Okay, let's just go through few things. So this is how the region server physical layout would look like. So if we have keys like A to Z, the keys would look like this. First reason is T to Z, and there is one reason, two reasons, three reasons, four reasons. These are six reasons. They are allocated on multiple machines parallelly. Okay, so this is how it would look like. So this is diagram is clear to everyone. All right. So this is a little ugly slide. Okay, don't get threatened by this. It's basically the Java code. Okay. So first of all, when you want to talk to HBase, you create a configuration object. Once you have created configuration object, basically here you define what are the server you're going to use for HBase and so on. After that, you create something called HBase admin. HBase admin object is the one which is going to do a lot of things for you, such as creating a table and listing the table. So this is going to be your command executor kind of a object. Okay. Then you create a table. First, for creating a table, you create HBase table descriptor, and for each HBase table descriptor, you then create column descriptor, and then for you add that column into the table. Okay, as a sorry, you create something called a column family, and you keep on adding all of that. All right, so that's how you create the table. If you want to create the table, if you want to list the table, you can call a method called admin dot list table. It will give you the hand list array of table descriptors which you can iterate over, and you can do lots of things you want. Okay, so it just for getting these few rows and few basically getting row one and the data inside it. That's all the whole thing has been done. Okay, so if you just copy paste it in Eclipse or something like that, this would look far better. Okay, so That's how you can access HBase. All right. Now, the other important aspect of HBase is that in case you want to do a churning on top of HBase, instead of downloading all the data from HBase and then do the churning, you can do the map reduce. So MapReduce looks very much like our HDFS MapReduce. Here, the only difference is the mapper has extend something called table mapper, and under that, it is given a row on which it can operate. Okay, and so on. So the way in HDFS we operated on line by line, here you can operate on row by row, and you can define the reducer in the same format. You extend the table reducer instead of normal reducer, and then you get a list of values and the key, and then you do whatever you want to do here. Okay, and then you basically bunch it together just like our config object. You you know bind it together and then run it. Okay, so when you are running it, you have to define an input table, and you can optionally define something called the on subsection of rows. You can define a parameter called scan, where you can define how much caching you want, and and okay, similarly you define your mapper class, you define your reducer class, and once your MapReduce util has initiated the job, you can say job dot wait for completion, and it'll wait and it'll give you the results. All right. So basically, the way the way we did a MapReduce on top of file, you can do MapReduce on top of tables. There we operated line by line. Here we will be operating on here you will be operating on row by row. Okay, so there are two ways to handle this. One is writing this kind of mapper reducer. The other way would be that creating a HBase table reader. Okay, that is using a different input split specifically for HBase, but that will be little inefficient as compared to this one. All right, so you can try it out. Alright, other than this, HBase provides you something called a REST service, which means HBase will become kind of a okay. So if we have a table called Ambari smoke test, and let's scan Ambari's smoke test. Why does it work that way? This time it same command worked. column family, column equals this, and we have got row 01, row 01. Why doesn't it work? Okay, so we need to check if we are running Stargate. Alright, so to run this thing, it's actually not running right now. We need to install Stargate server. So we've just started our Edge-based server on which port did we start? So we basically started at this port. Alright, here we have now this one. So it's doing something. Let's see what happens. So it downloaded us the data here, and this is the value inside that one. Okay, and you can see here, you can see here that that's the same value which is also stored over here, right? You can see that the same value is available over here. Okay, so when you downloaded this data, it gave us this file containing the actual data. Because the data is bytes and hence it gave us the file to download. Okay, so which actually means a lot to us, that we can build a server such that that makes an ajax call to this service and gets the data from there. Okay, sounds good to you? So we basically created our URL on this pattern. Okay, so this basically gives you a grammar of the whole URL. At the top is table, under that is row, then optionally the brackets say that optionally there is going to be columns, at least I mean brackets and then question mark, which means 0 or 1 and so on. Okay, have a look at the full grammar. So you can you can do the same thing from the command prompt. But the usefulness of a web service, of a REST call, is that you can host a website which is taking the data from here and starting to work on it. So you can have a very plain vanilla website which downloads data from here using Ajax, and then you might use a graph D3JS kind of graph which load the data from this place and display it using any of these graphs. All right. So does this sound good to you? Okay. So that is the significance of having a REST client. You could also use, just clean it up a bit. All right. Also, in case you are, in case you require sort of an SQL access to your HBase, you can use something called Apache Phoenix, which is similar to, which basically gives you a sort of JDBC driver which you can utilize to query uh, HBase. Okay. Now, there is something called a Bloom filter. Bloom filter is more of a concept which most of the interviews are thrilled to ask in the interviews. So they generally ask what exactly is Bloom filter. It's a cool concept. It's really a cool concept, and the idea is behind Bloom filter is the idea behind Bloom filter is to make the process really efficient when you are searching for the data. Okay, so instead of, if you have lot of queries coming to your data storage, so you have a data storage, lot of users are querying the data, give me this row key, give me that row key, and so on. But most of these times you realize that these row keys are bogus. Okay, meaning they don't exist in the storage you have. So it's a general concept, it doesn't only apply to HBase. It's a general concept which is utilized everywhere. You can also utilize in your own project. So when you have the this kind of a situation that most of the time you are looking for the data which is not there in your data storage, and your data storage is too humongous that even a binary search is not efficient, then you need to do something about it. Okay, so you build something called a Bloom filter, a smaller set of data by basically creating a hash code of the actual data you're looking for. And so are you guys with me, or you went off to sleep? Okay. All right. So I'm trying to explain that the Bloom filter is essentially, okay, I think let me take a step back. Okay. Let me take a step back. And all right. So imagine that there is a watchman in a building, or there's a security guy in a tech park which has a lots of people keep coming and asking to enter into the building, and all it does is the person comes in, it looks into the register, and then gives out tells whether to go ahead or not. Okay, it looks for something called ID. Okay, let's say 32 characters ID. Okay, now, and imagine that the register which security guy has 50,000 pages. Okay, so even to look immediately using a binary search into this register of 50,000 pages, it takes a considerable amount of time of this security person. Okay, it takes a considerable amount of time of this person. Now, what this security guy suggests that keep another level of security person. Okay, let's say level 2. Okay, so when a user comes in, first they go to the security level 2, and then they go to final security, the final one. Okay, now the security level 2 has got only the first two characters, has say first three characters of valid IDs. Okay, so if a user comes in, it just checks for first three characters, and the register of this person would have how big? It would be hardly 100 pages. Okay, hardly 100 pages, which, I mean, maybe total number of count will be say 26, 36 into 36 into 36. Okay, alphanumeric. Okay, 26 plus 10, 26 plus 10, because it's the three characters, so only these many values would be there. So security level 2 will be able to tell very quickly whether the first three digits are valid or not. Okay, so first three digits here represent the hash code which we have created on top of ID. So you'll be able to immediately, within few minutes, be able to check whether this person is valid or not. And close to 98% of the people will be returned from here itself. Okay, so only 2% people would be going to the final security check, and there it will do the most thorough one. Okay, this is exactly what a Bloom filter is. Okay, so here this first three characters of valid ID is just an example of a hash code. Okay, hash code could be something like sum up all the digits of the ID and divide and compute the denominator after dividing by 36. Okay, or divide after dividing by 255. So hash code could be as simple as that. Okay, and if this security guy is smart enough and these value hash codes is very small, say 200, this person can actually memorize all these 200 numbers and can immediately return a person, or can let him enter. So this security guy will become a very very efficient. All I'm trying to say is the secondary level, the Bloom, this is the Bloom filter which we have created. The Bloom filter can retain the data into the RAM to do a quicker check, and then if it passes, then it uh, again has to be thoroughly checked against this kind of a data. All right, so a user comes in, if the Bloom filter does not have that key, it returns it saying no, no, we don't have the data for you. Okay, So Bloom filter maintains a sort of a hash code which immediately computes it and returns it. And in case the Bloom filter says yes, the check is going to happen again at the storage level. All right. So basically, we have moved the bottleneck from the storage to the Bloom filter. Okay. Sounds good to you? Was I able to explain what is Bloom filter? So there are lots of people who ask the question on Bloom filter, even if you are nowhere related to big data. It's a very bad question about in lots of companies. Okay. So they generally give you a problem that this is the kind of search problem we are having. What do you suggest? Then you say that okay, you can actually utilize Bloom filter in order to make it faster. And Bloom filter is generally you know it's a 32-bit array kind of thing, which is basically, and you convert the IDs into a number and you look it up in this array quickly. They call it bit vector. All right. So that's what is a Bloom filter. So should we take a break? It's 10:15. Are you guys back? Should we start? All right. So just like you, do you guys know what is a trigger? A database trigger? So only Amit knows. Okay, Bindu also knows. Abhinav. All right. So yeah, exactly. So whenever, so a database trigger is something which like a function which gets triggered whenever which you can hook up to various events. So similarly, you have coprocessors in HBase. You basically hook it up to various events in HBase. All right. So you can basically create a function, create a jar, and then create an XML and add it into this one, and then that's all. Okay. Okay. So there are various kinds of coprocessors you can create, such as before before a value before a get is called on a particular value, or before a put is called, before a delete is called on a cell value, and so on. So there are many kind of such triggers which you can create. You can create things like who is allowed to access a data and who is not. Okay. All right. So that is one way. This is the way where you will have to restart HBase. But there's another way in which you can put your jar into HDFS and then can load it using this way. Okay, using this way, and then you can start using the coprocessors. All right. So let's say hello world. I think so. It will have definitely have Python binding. If it's not, I think it has a Python binding. Python client for, yeah, they have a, the Starbase has a wrapper over the REST API in Python. Now, to start HBase interacting with HBase, you just type, let me just shut down the REST interface, and you can say HBase shell, and it will start the shell. And after that, you can just check what's the status. It'll show you that 3 servers are alive, 0 are dead. And when you are starting it up, it will also show that there is a zookeeper being used. Okay. If you want to create a table, you can simply say my table, and this is the column family you can give. Okay. And it says the table already exists. All right. So we can say, Oh, so we can create a table, then we can list the table, and then you can use the regular expression while listing the tables. And while putting the values into table, you say put into this table this row, and this is my data. Sorry, this is my column name. This is my data. All right. And after that, you can say scan my table. My connectivity is actually getting badly hit. So you can see that it's really big here. And if you want to access one particular row and one particular column, you could use this kind of syntax for getting the value. And also you can say describe my table, and before deleting you will have to disable a table and then you have to drop the table. Okay. Also, you can have a look at the status of your HBase using this URL. This shows you the master status and a lot of detail about your HBase. Okay. Okay. So these are the reason servers which are available as of now, and these are the tables available. All right. So it gives you the details about everything. So you can utilize the this web service to see the HBase. And that's pretty much about HBase. Any questions on this? Okay. So Abhinav's question is, for structured data with billions of rows, which one is better to go with, Hive or HBase? So I would say HBase. Okay. Because HBase essentially provides you edits also. Hive does not provides you insert or update. All right. Hive is sort of a read-only view on top of the data. But now they had been working on the same thing. They have been trying to make Hive just like HBase by creating their own RC file format and whatnot. They're trying to make the Hive similar to HBase. So so your question would become valid after now after some time, and it is it's all a function of the performance after this new release of Hive. All right, so that was about NoSQL and HBase. All right, so let's start with the session number 8. HBase doesn't provide queries like Hive. You will inevitably have to use things like Hive to use HBase catalog. Okay, you will use HBase catalog to load the data from HBase. Yes, there's nothing wrong in using both. Yes, with HBase you can get the real-time data, but that would be using the direct API to HBase, not via Hive. So with respect to throughput, HBase is fairly high throughput, as in the data you can get is in real time. API calls are actually pretty fast in microseconds, okay, as compared to the Hive calls. Hive calls is in 5 to 6 seconds. If we compare HBase and Cassandra, so some people actually did some study and they found that HBase in HBase's Cassandra, the performance is comparable, but Cassandra is winning so far. Yes. Okay. So Cassandra is winning so far with respect to the performance. But when you already have HBase, the additional infrastructure is going to take more effort from your side. So Abhinav's question is that can we replace MySQL with HBase in production if our data size is really huge in terabytes? Okay. So Abhinav, the answer is, it's pretty difficult. Reason being, the approach used in both the HBase and MySQL are very different when you do the modeling of the data. As you saw today, that we were trying to store the data in the columns, right? While most of the data in MySQL is, the traditional one where columns are fixed. So generally, what you end up having is a altogether a different design when it comes to the big data, and the migration from one database to another leads leads to a different software also. Okay. So when you are migrating to, either you forego all the additional benefits HBase is giving to you, or you will have to re-architect the solution that which understands the data and presents to the user. Okay. So consistency in case of HBase and Cassandra differs a bit. Okay. In case of HBase, the consistency is, it's heavily consistent because it has the master kind of model where all requests go through the master. While in case of Cassandra, the consistency is tunable. You can choose 2 out of 3 in case of Cassandra. Right? You have already written that. Good. So if you generally have only the requirement of a database and nothing else, then Cassandra is a good choice. But if you have a requirement of the whole ecosystem, starting with the file system, then having Hadoop or HDFS is a better solution than Cassandra. and probably Cassandra, I think, works with HDFS also. All right, so let's discuss something called HBase. Sorry, let's discuss something called Zookeeper. All right, so let's start with. Okay, so as we saw earlier in case of HBase, when HBase wanted to communicate with with its reason servers, it used a service called Zookeeper. And Zookeeper is an important aspect. The There are few things to know about Zookeeper. Zookeeper is essentially a distributed coordination service, which makes the relation uh, between the users completely independent. Okay, so it is not for storing too much of data. It is good for storing small amounts of data. So you can imagine that as I told you, as I gave you the example earlier, you have a hotel reception and there are lots of guests waiting here and there and in the lobby, and all of them have informed the reception that in case somebody comes looking for them, just inform us. Okay, now this reception is what we call a zookeeper. The good part about this reception is there is always somebody available at reception. It's a highly available. In case one guy goes to sleep, there is another person waiting as a backup available on the reception, and so on. So this is that zookeeper. It ex- but as exactly like a reception of a hotel, it is not the room. It's not the place where you can put all of your stuff. You can put keys, you can put small stuff on the reception, but you can't keep lot of data. Okay, so that's what is Zookeeper. So Zookeeper is a service which provides a coordination between users and server, or maybe between multiple instances of one service. So the way the Zookeeper works is it provides you a data set, like a data type like a directory tree. It's actually the real representation of a tree in which you can create nodes, create children nodes. Each node can have some data and so on. Okay. It is fairly safe with respect to multiple threads, multiple race conditions, deadlocks, and all of this. It is extremely safe for synchronization. All right. Which means that in case you want the kind of features, synchronization kind of features, you could utilize Zookeeper instead of building your own system. So design goals, first of all, it's pretty simple. It gives you a hierarchical namespace which looks like a file system where you can store small amounts of data, and each node, which we call directory in file system, each node is called Z nodes or Z nodes. Each G node can have children G nodes, as well as each G node can have some data stored on it. Each G node is represented by a URL. Okay, and most of the data is kept into the memory, while there is a backup also onto the disk. Okay, now It's heavily replicated in the sense that zookeeper itself runs in a manner of on multiple machines parallelly. So there are multiple servers which are running zookeeper. One of them is chosen as master, and rest of them are followers. And as soon as master misbehaves, the master is dethroned, and somebody else becomes a master. So the design goal of Zookeeper is replicated, as in it runs on multiple machines simultaneously. The client of Zookeeper keeps a TCP connection. Whenever something happens, the client gets the watch events. Client keeps on sending the heartbeats so that Zookeeper knows that these clients are alive. Okay? And the client, when I say client, is a library provided by Zookeeper themselves, and the the client basically knows. So misbehave, as I said, misbehave means, say, one of the Zookeeper machines, which was running as a master or leader. They call it leader, not master. So if leader Zookeeper shuts down, stops sending heartbeats, other the other Zookeeper machines, when they are voting, they vote based on how well it has responded to the heartbeat. If it has not responded for quite a while, it is dethroned, and rest of the Zookeeper nodes elect a new Zookeeper leader. Okay, so basically this is a standard gossip protocol. So first is Zookeeper is kept very simple. I'll show you what does it mean by simple. It's basically a file structure. In very simple means, from the user perspective, it's like a file structure. It's like a tree structure. You put the data onto each node, you create children of the node, and so on. Okay. Second, it's replicated, which means that there are multiple zookeepers running. It's highly available, or you can say highly available HA. Ordered as in every every request which goes to Zookeeper is marked with a number, or every update with modification has a unique identification to make sure that the the update which came first happens first rather than the second one. Okay, so the transactions are fairly ordered. So Zookeeper is heavily, you know it's extremely fast. It utilizes memory, and it makes sure the load is distributed parallelly. And when the read to write ratio is around 10 to 1, it's extremely fast. And a Zookeeper cluster at Yahoo was tested on 10,000 operation per second, which is actually pretty good. So the initial one would be pretty simple one. This is the service which Zookeeper expose. If you want to just check, if you just want to check, oh, it's still running. Okay, so if you want to say here echo are you okay, and SSH, and we say NC localhost and 2181. Do you guys know that you can execute a command from remote using SSH? So it provides basically these kind of commands directly with which you can quickly test whether what's going on with our zookeeper. So I said, are you okay? It says, I am okay. You can see that here it says I'm okay. Similarly, you can check the configuration, you can check the environment, you can check the server statistics, and so on. Okay. To install Zookeeper is actually pretty straightforward when it is single instance, a little tricky when you're installing on multiple. But in case you're using Ambari the way we have used, installing Zookeeper is fairly straightforward. Ambari itself has the option of installing Zookeeper. Okay, so the data model looks like this. Okay, you have at the top slash, then you have a z node called zoo, and you can create as many as nodes you want. So a z node can have children, it has data, it it has a hierarchical namespace, and but there are a few differences. One, it doesn't have anything called file. Okay, everything is a z node. Second, so everything is a z node as in folder structure, unlike the file system where you have files which don't have children, but in this case everything has a children. And whenever you are interacting with a node, either you get the full value or you get nothing, you get an error. There is no such thing as partial reading the data from z node. Okay, so that's the model here. Okay, so you can see, I'll just connect to, let me go to, it's taking a little too much time. Okay, now there are different kind of zookeeper nodes. First is the normal one, second are ephemeral. Ephemeral as in ephemeral exists as long as the client who created this particular ephemeral node exists. They remain into existence only till the point the client is connected. The moment client disconnects, ephemeral node disappear. Okay, and these are the ephemeral nodes which make it possible for master to know that which region servers were available. So every region server, when they come alive, they create an ephemeral node onto the zookeeper. Okay, and based on these ephemeral nodes, the master knows that these are the region server available as of now. Okay, so ephemeral nodes are very important. So zookeeper. think I should just type it. All right. So, and also, so here I am able to now connect to Zookeeper. It says that welcome to Zookeeper, will not attempt to authenticate, initiating session, and session ID is this. I say ls slash. So you can see that these are the nodes available which are the children of slash. Okay. If I say slash kbd, this is what I'll get. Okay. These are the children node of kbd. Okay. So if you want to create create node, you can simply say create create slash anything which you want to do slash sg. Okay. And there you will have to define the data. Say here I'm defining some data. Now sg is created with this data. Now I can say get me slash sg. You get this data back. So it's pretty simple. It's actually extremely simple. So this one which we have just created is an permanent node. If I want to create an ephemeral node, all I need to do is say create minus e. It's taking a little bit of time today. All right. So we can say create minus e and we'll have the ephemeral node. Now there is a third kind of a node which is sequential node. These are very nice, very important one. Every time you create a sequential node, a new number is generated under a node. Okay, the number starts from 0 for each node. Say we are creating a sequential node called that starts with slash ju. Okay, which means that under slash, which is the root one, under root create the next sequence number, and every node, Z node has their own running count. So if you create a fresh node and you create a sequential node under that fresh node, the sequential node will start from 0. Okay, sounds good to you? So the number keeps on monetarily increasing. Each Z node has its own running count, and so on. All right. Now, there are cases when you want a notification from Zookeeper about some events, such as you want to be notified every time a node is created or node is deleted, or there is a data updation happening on a node. So the way you can create a watch is by the way of providing a handle at the time of creating a node. Okay. And here is the list which operation provides you what kind of watches. So a create operation, not this one, here. Okay. All right. So watches are something like you want to be informed whenever something is happening in Zookeeper, and they are triggered only once. For if you want to keep on getting triggers, so the moment it gets triggered first time, you have to re-register it, just like a Java. Oh, is the video stuck with everybody? So, all right, all right, all right. These are the various other functions which Zookeeper provides. It creates a Z node, deletes a Z node, and then test whether exist or don't exist. And each of these functions are capable of creating a watches also. Okay. Also, every operation like create, delete, everything can be batched together as multiple operation. And when you have a multiple operations together, they are atomic in nature. Either all fail or nothing fails. Okay. So it's and that's how the transactions are implemented when talking to a service like Zookeeper. All right. And why Zookeeper is able to do all of this? Because Zookeeper does not provide you a great amount of space or great amount of storage. If you start increasing the data you are storing in Z node, it will start becoming slower and slower at a faster pace. All right. For every function, Zookeeper provides you two kinds of signatures. One is the direct one, where you ask a question and Zookeeper replies or makes you wait till it replies. That is synchronous. And then every function has got another form also called asynchronous, where you ask a question, it says that, okay, I have listen to your question. Now go home. Whenever I'm done, whenever I have the answer for you, I'll reply, I'll send you an email. That is asynchronous. Okay. So asynchronous and synchronous are the standard paradigm of programming, where in one, uh, you ask the question to somebody and it replies. In the second one, you ask a question and they reply at their own pace. Okay. They say that, can you leave your phone number? I'll call you when I'm done. So that's what it is. So which means then you have to leave your phone number, and that phone number here is the callback. Here you have to provide a function called callback. So whenever this function exist is done, once it finishes checking whether a particular path exists or not. After that, it will make a call to your function called CB. Okay. So that's the state of APIs provided by Zookeeper in almost all languages. The basic one is in C, and then Java, and Perl, Python, and Rest are basically the binding on top of the C one. And every API, each binding, whether contributed one by the public or the core ones, all of they have synchronous and asynchronous signatures. So based on your requirement, if you want something, if you are okay to wait till Zookeeper finishes a work, you use synchronous call. If you want that, let Zookeeper finish at its own pace while you finish something else, then you use asynchronous. Okay. So whenever you are doing exist or get data or get children, you can define something called a watch, programmatically. Watch is another function which you can provide while creating these things. And watch is basically, you can see, you can define an object called watcher and you can pass it as an argument. And watch that were created when you called a function called exist will be executed when that particular node on which the exists were called. So you did exist, you checked whether a slash do exists or not. At the same time, you provided a watch function as well as a callback function. So callback will be called as soon as checking for slash do is finished, and watches will be triggered when slash do is either deleted, or in case it did not exist, it got created, or its data got updated. Similarly, when you called get data slash kbd, okay, you passed a watch, you passed a callback. Callback will be called as soon as the get data is finished, and watches will be called when the data of that node is either deleted, or the node itself is deleted, or the data got changed. And get children, if you want to know the children of a node, you can also pass two things. One is a callback, other is a watch. Okay, and those watch will be triggered when the children are deleted, when the node itself is deleted, or its children is created, or a child is created or are deleted below a node. Okay. And then there's something called access control list. So Zookeeper provides a way of securely handling the data. You have multiple ways of authentication. The most common one is Kerberos, which means that based on the local authentication scheme, it's already bound. Or you can have IP kind of thing, that only people from these IPs can make a connection to the Zookeeper. Or a digest, as in you provide login password. You provide login password while establishing a connection. And these are the standard ways of connecting. So access control list comprises of authentication scheme, an identity for that scheme, and a set of permissions. Who can read which node, who can delete which node, and who can update which node. Alright, so architecture is essentially two kinds of things. One is standalone, which is of course for temporary purpose, only for development or testing. It's not good for real time, because the whole purpose of Zookeeper is defeated if it it is not highly available. The whole purpose of a hotel reception is defeated if there is nobody sitting at any point of time in the reception. Okay, the cluster of machines which are running Zookeeper is called ensemble. An ensemble runs as long as majority of machines are alive. Okay, so basically the architecture is important. The same architecture is followed in Cassandra, as well as the same architecture is followed in MongoDB. This is called something called gossip protocol. Okay, so this I mean, just be with me for some time. So have you ever heard about gossip protocol before? Nice. So this is probably the, yeah, standard one. You will encounter it at multiple places when you talk about distributed computing, and is one of the important things. In a gossip protocol, or in a system like Cassandra, MongoDB, and Zookeeper, there is no leader predefined. Unlike our name node architecture, where we said that this particular machine is name node and rest are data node. In case of Zookeeper, we just say that these are the bunch of machines which are running Zookeeper. We don't say that this particular machine is a leader. The role of a leader is accepting the rights. Meaning, if you want to write the data, you talk to the leader. Hello? Was there a disturbance? Alright. So whenever you want to write some data, you always your client, the library client library, it is going to talk to the leader and write the data. If you want to say get, sorry, not get, put, delete, and set, those kind of commands. In those cases, the request is going to go to the leader. Okay. Now, who is the leader? We did not designate any leader. These bunch of machines on which we started Zookeeper, they know who are their peers. They know the IP addresses of other zookeepers, and they started talking to each other. And by talking to each other, they designated by themselves a leader amongst them. Okay. So machines elect a distinguished member called leader. The others are termed as followers. Okay. Once a leader is selected, once leader is selected, the state of all the other nodes, other followers get synchronized from the leader. Meaning all the writes are being accepted by leader and others are synchronizing with the leader and making a copy. So majority, when I say majority, more than 50%, if they have synced their state from the leader, everything is fine. If the leader fails, the remaining machines hold the election within, and this takes around 200 milliseconds. So there is a downtime with respect to writing of 200 milliseconds. So for these 200 milliseconds, there is no leader available, which means users will not be able to write during these 200 milliseconds. Okay, which is zero point 0.2 seconds. Within zero point 0.2 seconds, there is going to be election. Somebody is going to get elected and become the leader and start accepting the rights. Right? So all the write requests go to leader. Leaders broadcast the updates to all the followers. When majority have persisted the change, leader responds to the client saying, "Hey, I'm done with writes." And the client gets a successful response. Okay. The protocol for achieving consensus is atomic. Okay. Also, when machines are writing, they write to the disk before marking it in the memory, which means the change is permanent. There is no such thing as failure. Okay, because the bigger chance is, unlike in case of Hadoop, when it was doing sorting for you, it was first writing to the memory which was being spilled over to the disk. Here it's the other way around. And all right. So whenever a client is going to connect for writing, the follower itself will forward the request to the leader and the writes will start happening on the leader. Now, one more thing to notice in any gossip protocol, for the selection of leader, you need at least 50% vote. If you have three members, at least 50%, as in two members, should be alive. Okay? Only one can become dead. If there are two become dead, then there cannot be any leader. Okay? So if you have five machines, okay, if you have five machines, zookeeper clients, you can say zookeeper machines, how many machines, how many machines should be alive for selecting the leader? So it can only tolerate, although we have five machines, but it can only tolerate the shutdown of two machines, right? And can anybody tell me why is it so? Aren't we wasting our ability to tolerate the errors? When we have two machines, it should keep running, right? Can anybody tell me why is it so? In case at any moment of time machines go below 3, if 3 machines are shut down, only 2 machines are left, there will be no leader, the whole system will become the read only. You will not be able to write to zookeeper at all. Any ideas why is it so? Anyone? In any gossip protocol, when the election happen this way, you need at least more than 50% of votes in order to select a leader. And can anybody help me understanding that part? Why is it so? You may elect yourself to the leader and there will be a conflict. Okay, that's a very good point. But that is for more than 50%. Okay. Why can't, if you have, say, 10 machines and 6 out of 10 machines, 6 are up, 6 are down, let's say 6 are down, or 5 are down, only 5 are left. Why don't they, these 5 remaining one, hold the election, choose the best one, and be happy? The capacity is half. Why is it so? Okay, Gnode is a conceptual thing. It's inside the zookeeper. Okay, it's a directory structure inside zookeeper. So maybe you need to say that maybe the majority informed about the leader. Okay, all right. So imagine this: one node was shut down, and rest of the people hold the election and choose a leader. Then second node shuts down, they choose some other leader. And this keeps on going. The moment the fifth node went down, there is no longer a leader. And there is a very good reason for it. There is a very brilliant reason for it. Okay. Now let's have a look at it, what happens in that case. So, okay. And there is a very important reason. It took me a little while when I was trying to understand why architecturally, why didn't they let this happen. Okay. So let's say you have three machines, A, B, and C. A is the leader. A shuts down. What happens next? Okay. What happens next? Can somebody give quick answer? Who becomes the leader? Yes? No. Actually, majority is still there. Majorities two are still there, right? A node can vote for itself. Okay. All right. So either B or C are going to be the leader. Either of them, whosoever has the best ping performance. So right now there is no conflict per se. It's just that when each other is voting, they are honest people. Unlike in a democracy like ours, they are honest people. They basically have give out their proper response in terms of ping times. If C pinged B, B pinged C, they reconciled the numbers. Hey, you are faster. Let's make you the leader. Okay. Now the next thing happens that B shuts down. So ideally, C should have been the leader. Or let's have a look at this way. Now C was the leader and B shuts down. So should C step down or not? Should C step down? Anybody? C steps down because there is no majority of people available to support him. Okay, and let's have a look at why exactly is this. Now imagine there were two data centers, data center 1 and data center 2. All right, there were total 6 nodes were there, and A was the leader while rest were followers, while these exist in two different data centers. Now suddenly there was a disconnect here between the wires connecting the two data centers. Now there are two bunch of computers, DEF and ABC. They know each other, they can vote for each other, right? And make somebody leader. Now what if there becomes a leader on the left hand side, the data center 1 as well as the data center 2. Now there are two leaders, both of them are accepting the rights from the other part. Both of them are independently accepting the rights, and hence there'll be a humongous inconsistency, and the whole purpose of the quorum is defeated, right? And that is why it is mandatory. Now imagine this, he will say that I need, so when both of data center 1 and data center 2, they will say we were informed in the beginning that there are total 6 nodes and we are getting only the votes of 3 people, which means we haven't had the majority. And if we don't have majority, there are chances that there has been a partition in the data center. All right. That is why in no way you can partition a network such that there are two sections and both sections have more than 50% majority. Okay. You cannot divide something into two parts such that both parts are bigger than half, right? That is why that protocol is designed in a way that to select a leader, you need a 50%, more than 50% of the votes. So, was I able to explain to you why do we need majority votes? Amit? Okay, maybe you guys are thinking. Think about it. Think about various combinations. Imagine that you put the scissors here, instead of here, let me just put the scissor somewhere. Let's say I put the scissor here, okay? Or maybe one more here. Now F got disconnected, but still there is a majority. And imagine this. So are you convinced about my argument, my point? All right. So now quick question. In a three machine scenario, two go down, as in out of three, two are down. Then if the third steps down, the system will go in read-only mode, which defines the whole purpose of efficiency. No, I didn't get this. So you mean to say here, the C should not have stepped down as per you, right? For the efficiency purpose? Yeah, that's what I'm describing. Imagine this. A, B, and C, all these three are in different data centers. One of the data center goes down, okay? Or the connectivity between these three data center goes down. Now you have three different leaders accepting writes from three places, okay? The whole purpose of a leader was a leader has to accept the rights so that the rights are consistent. If there are two machines accepting rights, there will always be the conflicts. You will never have the consistent data. Right? Now, an ensemble of 10 nodes can tolerate how many shutdowns? Quick, quick. So if only C left, no one accept. Yes, no one will accept writes. The whole system will become the read only. Yes. An ensemble of 10 nodes can accept a shutdown of 4. Excellent. Alright, should we take it tomorrow? I mean, on the next weekend? So these are the guarantees, and let me just give you an example. So when you are building a high throughput system, this is diagram I would like to explain to you, which is more important than anything else. So there are these so many clients which are trying to connect to your server farms. They all of your server farms is basically the websites which is are providing some service, and user can connect to any of these server farms. Okay. So that's where the zookeeper comes into play. All of these servers are going to create one ephemeral nodes with their IP address as the data. Okay. And whenever users are coming and saying that can you connect me to a server, they generally look up in that folder, they do an ls on that particular z node where all of the ip addresses are available, and then pick up one of the ip address and start working on that. Okay, so zookeeper basically made your system highly available. Okay. Also, this client can do one more thing. The moment they start using a server, they increase the number of counts of requests on that server, so that the other users, other clients, when they come, they can check how many people are reading from it. Okay, these many. That means it will not read from that particular server, it will read from somebody else. So this way, Zookeeper provides the coordination between highly available services. All right, so let's discuss on next weekend. This is an example you should try out by yourself. It is actually pretty straightforward. I've given you examples already. Try out this by yourself and let me know in case you face any problems. All right, so this is the hands-on exercise. You should give it a try. And there are many more use cases. There are infinitely many use cases of Zookeeper other than building these configuration service. At Amazon also we had some sort of a configuration management system whose objective was exactly uh, what this Zookeeper provides. Okay, all right, so that's pretty much, and let's meet next weekend and have the discussion further. Okay, so you two have a good week ahead, and so everybody have a good weekend. All right, thank you very much, and it was a wonderful session. All right, thank you. And please refer to your friends about our upcoming course if you really like these sessions. Refer to your friends, and then, all right. So your friends generally get a 10% discount, and you get generally 10% refund. Yes, tell me, Sushant. Yes. So tomorrow onwards, there is going to be a Java session. Yes. Okay. So for all our candidates, all our students, it is free, and the people who are attending the classes now are given the preferences over the existing old students. All right. So those who want to attend the Java session, we'll see. I'll see you tomorrow. Okay. So assignment for this week is, first you finish up the Hive assignment. Second is you finish the try out all of this and send me the screenshot. Okay. All right. Have a great day. Bye bye.